Hi, this is Nitin from FTC Team 18172, Uplift Robotics, and in this video, I'll be demonstrating some of the capabilities of PTC Creo. These are some of the concepts I'll be going over in this demonstration, but I'll get more into this later. For this demonstration, I've made a simple shooter assembly to simulate the motion of this ball. I've already made the assembly, so I'll go ahead and show some of the steps I took in order to make this. Before getting into the actual simulation, there's a few different things that we need to do. One of which is to define kinematic constraints for each of these parts to move. For the shooter wheel, I've defined a pin constraint so that this wheel can rotate along an axis. Typically this would be along an axle, but for this demonstration I've just created an axis. For the ball, I've created a 2D planar constraint so that this ball can rotate and translate along in a 2D space. Now that we have the kinematic constraints set, I can go into mechanism mode and begin to simulate some of these components. You can access this by going to applications and hit mechanism. So now that we're in mechanism mode, there's a few relationships that we have to define between the components and the ramp. So the first relationship that I'm going to define is the cam connection between the wheel and the ball. So you can access this by going to cam. So I already have my cam connection defined, so I'm just going to access it from the mechanism tree. So in the cam connection, you can select a curve along these two surfaces. So I selected a curve along the surface of the ball and the wheel, and then I enabled friction between the two surfaces in order to get a more accurate simulation. Next, I created a 3D contact between the ball and the surface of the ramp. So you can access that right underneath the cam dialog. I already have mine set up, so I'm going to access it from the mechanism tree. And you can see the two surfaces selected and the surface of the ball also selected. And then also the friction is also enabled. So now that we have these relationships defined, we can create an initial condition in order for the ball to move into the shooter assembly. So you can access that from right here, or since I already have mine defined, I'll take it from here. So for an initial condition, I've set a velocity along an axis for the ball to move into the shooter assembly. And this is just an arbitrary value, and you can always mess around with this value as well. So now we have everything defined for an analysis to occur. So now we can begin to simulate the motion of this ball by going to mechanism analysis and setting up a dynamic analysis. So for my analysis, I've selected the type to be a dynamic analysis in order to simulate all the relationships that I've defined. For the external loads, I've enabled gravity and the friction that I've already defined in the model. And I've also allowed for the motor to run. Here you can define the duration and the frame rate. I've already done so. And the initial condition that I set up earlier is also included in here. So now I can hit run, and the ball is simulated. And now you can see that the ball has been launched. So I click OK. Now there's a playback feature for this motion that I can click and see how this ball is moving in reference to this model. So I can see that the ball is traveling here. If I wanted to take this motion and make it into a MP4 or an MPEG movie, I can capture this and change the resolution and also render the frames. One last thing, you can also click the measures box and you can generate some graphs based on the position of the ball as well. So if I wanted to generate a graph of the position of the ball at all times, I can hit the graph type to be a measure versus measured graph and define different measures. I already have my measures defined, one for the X component and one for the Y component. So using the analysis definition that I have, I can generate values, and using the second measure for the y-axis and the first measure for the x-axis, I can generate a graph. So you can see here that this graph that was generated shows the motion of the ball as it goes through the shooter assembly and gets launched up into the air. This type of simulation is really powerful for FTC teams because it allows us to adjust things like the angle of the shooter hood or the RPM of the shooter wheel in order to influence the trajectory of the projectile. And all of this can be simulated rapidly within Creo. This also saves time and money in terms of manufacturing and buying parts, which might not result in an optimal mechanism. Thanks for watching, and stay tuned for more tutorials on CAD and other aspects of FTC as well.